Hello guys, welcome to second law of thermodynamics, and we're doing a very important topic, that is petrol engine. And this is the figure for the piston system of the petrol engine. Now we have an inlet valve to let in the working substance, which is 98% air and 2% petrol vapor. And the spark plug is there to ignite the mixture of the working substances, and the outlet valve to let go of the working substances. And we have a rod and wheel to continuously move the piston inward or outward. Now we have a PV graph, and here if you understand this graph very well, then you will have no difficulty in understanding the petrol engine system. So first we have a point O where the volume is 0. Now, essentially, we have 4 strokes. The petrol engine, also called auto engine, is also called 4-stroke engine. Now, for the 4-stroke, it's called suction stroke. Here, the inlet valve opens and the working substances gets in the cylinder, and at the same time, the piston moves outward, thus the volume increases. So, let's say at a point A. Now, the pressure remains constant because, if the working substance gets in the cylinder, the pressure increases, but at the same time, volume increases, thus pressure decreases. And these increase and decrease in pressure cancel each other. Now, this is represented by OA. Now, for the second one is called compression. And in the compression stroke, the inlet valve closes and the piston moves inward, thus there's a decrease in volume. But since there's a decrease in volume, there must be an increase in pressure. So, let's say around here, point B. Now this is represented by AB. So here, the pressure increases to 5 atm and the temperature to 600 degrees Celsius. So that means this is an adiabatic adiabatic compression, right? Since all PVT changes. And also, if we say that this is the volume 1 and this is volume 2, then here rho represents the compression ratio, which is V1 by V2, which is approximately equals to 6. So that means the volume compresses to almost 1/6 of its original volume at point A. Now for the third one, is called the working stroke, and this is a two part in the graph. So first, the spark plug ignites the mixture. That means keeping the piston fixed. That means if this mixture gets ignited, that means the pressure rises and also the temperature rises very much. But here the piston remains fixed. That means it is a constant volume. So pressure rises to here, let's say at point C. This is BC, but the working stroke is still not over yet. So pressure here rises to 15 atmospheric pressure and temperature to 2000 degrees Celsius. And here, due to the spark plug ignition, the system gains heat Q1, and it is also called ignition. Now, at point C, the spark plug starts to cool off, and the piston moves outward, thus there is a decrease in volume. So this is an adiabatic expansion, like this. This is CD. So in fact the working stroke is BCD. Now for the fourth one is called an exhaust stroke. Now at point D, the outlet valve opens. That means the working substance is released from the system. At the same time, the piston is fixed. That means the volume doesn't change, and the working substance getting out of the cylinder means that the system loses pressure, right? There's a massive decrease in pressure, keeping the volume fixed. So is like this. It is dA, and again keeping the outlet valve open, the piston goes inward all the way to original position O. And since, well, volume decreases with the outlet valve open, the pressure increases, decreases, cancelling each other, having constant pressure when it also reels back in, right? So here it is AO and the exhaust valve is DAO. Now let's talk about the efficiency of a petrol engine. We have the efficiency formula. Oh sorry, at the exhaust stroke at point DA, it loses heat Q2 because, well, the working substances exit from the system. So efficiency is 1 minus Q1 by Q2 into 100%. But here, due to some derivation that we don't require for a SLC syllabus, this will be equals to 1 minus 1 by the compression ratio whole to the power gamma minus 1, where this is the ratio of the specific heat constants, into 100%. And since we know that rho is almost equals to 6, so efficiency is almost equals to 52%. But here in the practical world, in reality, I'll write practically, efficiency is almost equals to just 20%. So this is all for the petrol engine. If you learned something new, please like and subscribe. And thank you.